Hi, my name's Kevin. Today I'll be presenting the core of my doctoral thesis, which is a pilot study called Can You Beat the Music? A mobile serious game to improve sensorimotor and executive functions in children with autism. In this pilot study, children were selected as a model population to study the effects of a sensorimotor synchronization training. Since sensorimotor abilities are fundamental building blocks for good social and communication skills, we think this is an interesting avenue or new entry point for treating symptoms related to autism. These usually include deficits in sensorimotor and social domains, repetitive thinking and behaviors, as well as certain executive functioning tasks. Executive functions are considered efficient when they are accurate, but also when they are very fast in terms of timing. In here, if you look at the graph, we see that the timing system is linked in the brain to the motor system, the reward centers, and attentional processing. So here, sensory motor synchronization training could improve internal mechanisms in the brain related to timing, which can then transfer beyond that trained motor domain to other skills like rhythmic abilities and executive functioning. So this was a proof of concept study. Here we used a music-based rhythm training as our sensory motor synchronization training. It was played on a tablet as a form of serious game, so the purpose was not only entertainment. The game is called Rhythm Workers, and it has been used before in healthy adults and in Parkinson's to train rhythmic skills. Here we adapted this version to make it suitable to train in children. The first aim of this study was to examine the compliance, the motivation, perceived difficulty, and emotional state of the participants. So here we are looking at acceptability of the game and usability between each games. The second aim of this study will be to determine the effectiveness of the training in terms of rhythmic skills. So does it improve rhythmic skills? And as an exploratory aim, since it's just a pilot study, we'll also look at the executive functions, so the FAR transfer, to see if any of those improve in children with autism after playing Rhythm Workers. So in total, 26 participants were included in this study with an autism diagnosis. They were aged 7 to 13 years. We didn't include any comorbidities. They were each randomly assigned to either the Rhythm Workers game or the control game. They were matched on age and on IQ. And we asked the participants to play for 2 weeks, roughly around 300 minutes in total. And that is half the dose that we are planning for a future randomized control trial. So let's have a look at the game Rhythm Workers now. The goal here is to score points by tapping on the beat consistently. You lose points when tapping is not aligned to the beat. And the goal overall is to construct a building within a time frame by scoring more points and by scoring points more efficiently. And here we increase rhythmic difficulty as the game progresses. So that is the manipulation that we're doing. In Frozen Bubble, this is a puzzle arcade game that involves shooting bubbles. Here we used the same music, a similar amount of motor movement, a similar level of graphics. However, there was no motor synchronization to the beat in this game. That's the main difference with the experimental game. We assessed participant compliance by comparing the total amount of motor activity in finger tapping, the cumulative amount of time in the game and playing the game, as well as enjoyment and perceived difficulty of each gaming session. Finger taps, session time, and playing time were retrieved from the tablet log files. Participant self-reports of session times and dates were cross-checked manually with log files for overall coherence. Participants were asked to circle their level of enjoyment and perceived difficulty at the end of each gaming session on a 5-scale smiley face Likert scale. The means of all sessions for enjoyment and perceived difficulty were then calculated as a cumulative measure of appraisal of the game that the participants played. In order to measure rhythmic abilities, we used the battery for the assessment of auditory sensorimotor timing abilities, whose acronym is BASTA. So this battery was developed in our laboratory, and available on tablet devices. It assesses the perception and production of rhythm using tests to detect rhythmic irregularity in audio sequences or tapping on the rhythm of various auditive stimuli like metronome or music. We selected the most relevant tasks for our study based on previous work by Pujarine and colleagues and a pilot study done in our lab in 2019. Let's take a look at the results now. In terms of compliance, we see that participants played equally around 300 minutes for both games. And this is the amount of time that was logged on the tablet. We also logged the exact number of taps, and here we see that both groups are equal in terms of the motor movement, which means that the only difference is the synchronization of the tapping. After playing the game for 2 weeks, we also see that both participants were generally equally motivated and felt positively about the game. We also recorded perceived difficulty at the end of each session, and here we see that the mean of the sessions are equal in terms of how they perceived the difficulty when playing. A composite score representing the overall rhythmic production ability was calculated by merging the Z-scores from two rhythmic production domains. Different scores for each time point were determined based on the mean and standard deviation of the pre-intervention scores from both games combined. Here we see an improvement measured in standard deviations from the mean baseline before the intervention. The children on the autism spectrum who played rhythm workers significantly improved in rhythmic production after the intervention, but not those who played Frozen Bubble, the control game. These are still preliminary findings, and we are currently analyzing the effectiveness of the intervention on executive functioning. So, to conclude, let's look at how this pilot study contributes to our understanding of entrainment, music training, and mental health. Firstly, in terms of feasibility, our findings show that children on the autism spectrum complied to our protocol. Both games are well matched and optimized to use in an upcoming randomized control trial examining rhythm-based training in autism. We also see that playing Rhythm Workers, the game that trains beat synchronization, generalizes to other domains of rhythmic production, such as tapping to music and tapping to a metronome. And this was shown by a specific improvement in the production measures of BASTA for those who played Rhythm Workers. Future analyses will look at the effectiveness of the training on executive functioning skills like inhibition control and cognitive flexibility. An important element of novelty in this protocol is that it does not rely on social interaction. This feature can also make children with autism more comfortable with the training, since autism is characterized by a lack of interest in socializing. Here we're also able to isolate an internal mechanism that's related to rhythm, which likely generalizes to other functions in the brain that also rely on timing abilities. This protocol, therefore, helps us to tease apart the mechanisms in music training that drive improvement and that are based on entrainment. Thank you very much for listening, and I'm open to answering any questions now on the Zoom.